Dear student, Bismillahirrahmanirrahim. Today in this slide we will discuss turning reactivity with water. The group 1 metals become more reactive toward water. The only group means the only group, the mode of it given of increase as you go from lithium to caesium. Reaction of alkali metal with oxygen. Alkali metals react with O2 or air rapidly and get tarnished due to the formation of the oxide on the surface of the metals. It is for this reason that alkali metals are stored in kerosene or paraffin oil. When lithium burn in O2 gives mainly lithium monoxide. When sodium metal burn in O2 forms sodium peroxide and other alkali react with oxygen to form super oxides. Since the normal oxides of alkali metal other than that of lithium are not formed by the direct reaction between the metals and oxygen, they are formed by indirect methods like by reducing peroxides, nitrites and nitrates with the metal acid. Here the chemical reactions of peroxide, nitrite and nitrates with metal has been shown where normal oxides of sodium metal are formed. Properties of oxides. Normal oxide react with water to form hydroxide by proton exchange. Here you can see oxide ion gain proton and water release proton. As a result, hydrogen ions are formed. Peroxides and superoxides are strong oxidizing agents. As a result, they react with water to form hydrogen oxides and oxygen. Normal oxides has anti-fluoride structure and are ionic in nature since they contain monoxide ion. Peroxide contain peroxide ion. The superoxide ion has 3 electron bonds as shown below. The presence of 1 unpaired electron in it makes this in paramagnetic and colored. Reactions of the oxides with water and dilute acid. First of all, the simple oxides. These are simple basic oxides reacting with water to give metal hydroxide. For example, lithium oxide react with water to give a colourless solution of lithium hydroxide. And reaction with dilute acid. These simple oxides are react with an acid to give a salt and water. For example, sodium hydroxide. Sodium oxides will react with dilute hydrochloric acid to give colourless solution and water. The peroxides. Reaction with water. If the reaction is done in ice cold, a solution of the metal hydroxide and hydrogen peroxide is formed. If the temperature increases, the hydrogen peroxide decomposes into water and oxygen. This reaction can be very violent overall. Reaction with dilute acid. These reactions are even more exothermic than ones with water. A solution containing a salt and hydrogen peroxide is formed. The hydrogen peroxide will decompose to give water and oxygen. If the temperature rise again, it is also impossible to avoid this. Another potential violent reaction. The superoxides. Reaction of superoxides with water. A solution of metal hydroxide and hydrogen peroxide is formed as a reaction of superoxide with water. But here oxygen gas is given off as well. Once again, These are strongly exothermic reactions, and heat produced will inevitably decompose the hydrogen peroxide to water and more oxygen. Means again this reaction is violent. Reaction with dilute acid. This reaction are even more exothermic than ones with water. A solution containing a salt and hydrogen peroxide is formed together with oxygen gas. The hydrogen peroxide will again decompose to give water and oxygen as the temperature is rise. Reactions of the elements of first group with chlorine. Sodium bonds with intense orange flame in chlorine is exactly the same way as that is does in pure oxygen. The rest of the metal also behave the same in both gases. In each case, there is a white solid residue which is the simple chloride. This is nothing in any way complicated but about this reaction. Effect of heat on nitrate, carbonates and hydrogen carbonates of the elements of group 1 element. Group 1 compounds are more stable to heat than corresponding compounds in group 2. Lithium compounds behave similarly to group 2 compounds, but the rest of group 1 are in some way different. The bicarbonates are highly stable to heat. With increase of electropositive character from lithium to caesium, the stability of this salt also increases. The nitrates decompose on strong heating to the corresponding nitrite and oxygen. Exception lithium nitrate. Explaining the trend in terms of polarizing ability of the positive ion. When alkali metal cations approach near an anion, attract the outermost electron of the anion and repel the nucleus. Thus, the distortion or polarization of the anion takes place. This distortion results in the sharing of electrons between two oppositely charged ions, i.e., the bond between the cation and anion becomes partially covalent in nature. In general, the summary cations polarize the anions more effectively than bigger one. Therefore, the lithium salt are slightly covalent while other alkali metal salts are ionic. Student at large, there is a small quiz. You should solve this question after completing your lecture. Okay, Allah Hafiz.